Good day everyone, I'm Ashley A. Jimenez, and today I will walk you through how transition table and transition diagram works using two examples of finite automa. Now the things that I will be discussing is based only on what I have understand in a video presentation presented to us by our professor. So these tools help us to understand how a machine recognize or can recognize specific patterns in a strings of input. So let's first start with the first problem, creating an automation that accepts only strings that ends in ABBA. Now here's the transition table and the transition diagram. So each row represents a state, and the column shows where the machine transition based on the input either A on B or B. So Q4 or state 4 is the accepting state. So when we reach it after reading ABBA, the string is accepted. Now think of the machine like this. It keeps tracks of recent inputs. If it is ABBA in that order just before the end, it transitions to state Q0, Q1, Q2, Q3, and Q4. So now here's the transition diagram. If you will look at it, the states are shown as circles and the arrows represents the transition based on input. So the machine starts at Q0 and follows the rows depending on whether the input is A or B. So the diagram gives us a visual map on how the machine processes the string step by step. So in this diagram, when the machine reads an A, it moves to the next state, and when the machine reads an B, it moves to the next step again, and so on, just like in this diagram. So if the last four letters are ABBA, so the machine reaches the final accepting state. If the pattern breaks, it goes back or stays. So quick example. For example, the string BBA is accepted kasi it ends with ABBA. Pero if the string is ABBA, it is rejected because it does not end correctly, or meron siyang pasobrang A. It does not really ends with ABBA. So maybe nagkaroon ng error. That's why it's rejected. So now moving to the second problem. The second problem is we were asked to create a string that accepts strings that starts with AAA and with a BBA. So as you can see here, I have an typo error. I put AAAN, but it's supposed to be AAAA. So the transition table shows state 0 to state 1 on A, starting it with the AAA sequence. Then Q1 to Q2 on an A again, and Q2 to Q3 on an A again. Now we've matched AAAA. From there, the automation waits to see if BBA comes later in the string. So once we match AAA, BBA, we transition to Q7, and then finally Q accept. So Q7 and Q accept is just the same. If any wrong sequences is encountered, the automation goes to a dead state called Q-dead, where no more accepting is. So again, if any wrong sequence is encountered, the automation goes to a dead state called Q-dead, where no more accepting is possible. So here's the diagram. Now, the diagram shows the same logic as the table, but with a flow of transition. Based on A and B, we can visually trace the full path from AAA to at the start to BBA at the end. So I created states to check the start first, then allowed any characters in the middle, and then finally check if the last BBA at the end. If the string matches both, it is accepted. So here in the diagram I created, I inputted AAA, B, BBA. So I allowed any characters like B in the middle, which does not affect the string because we are only asked to make a diagram or a transition diagram that starts with AAA, which I made, and then ends with the BBA, which is the table or the diagrams that ends with the BBA. So I allowed two characters in the middle, both B, that does not affect the diagram or the string. So but if I inputted AAB, AABBA, it will be rejected by the machine because it does not end or it does not start correctly because it started with an AAB. So that is all that I have understand during while watching the video presentation sent to us by our professor. So I hope I have understand it correctly, but if not, I will do and try my best to learn more and understand deeper the transition diagram and transition table. Thank you for watching.